And this goes for anybody. So remember, I want to hear participation from everyone today. So who can tell me, how do I know that this is in standard form? What are some features of this equation that we notice that give it away? We wrote this down the other day. Who can tell me? Not one person? Do I need to go back to what we learned on Monday of this week? Come on, guys. Let's hear it. How do I know that this is in standard form?
Because of their it doesn't have parentheses.
It does not have parentheses. That's it. That's it. That's it. No parentheses. That's how we know that it's in standard form. Again, I did that on Monday. So remember what I said already. I am not reteaching anything today. So if you hear something today that you don't remember or that you're not sure about, you have to go back and watch those videos as a review. I do not have the time to teach things again. I simply do not. I wish I did, but I don't. So it is your responsibility to make sure that anything that you don't remember today, you go back and you review. Especially since y'all have a nice break now, that is a good time to go back and review things, especially since we have a test as soon as we come back. So it's in standard form. Which means that since it's in standard form, what does standard form tell us about a function? What do I know about this function based on the numbers in front of me?
We know the y-intercept, the a, and that's it.
Okay, so what's the a value?
The a value is -16.
And let's actually go through each of them. What's the b value?
+32.
And therefore, what's the c?
0.
0. So I have my a, I have my b, I have my c. C is the what?
Y-intercept.
It's the y-intercept. C is the y-intercept. And what does a tell us?
The width and direction.
Good. So in this case, I have a -16. So what direction is my graph facing?
Downwards, and it's stretched.
Okay. And that's a lot of information. So what I'm going to do is I don't have a graph in front of me. I just have a word problem, but I'm going to do a little sketch just to be able to kind of understand what's happening. I know that my y-intercept is 0. It's at the origin. And I know that my graph is downwards and stretched, so I know it's going to go something like this. Now, I don't know what any of these numbers are actually going to be, but I have an idea of what the graph is going to look like. Does anyone have any questions on my sketch of the graph? Now, what does the x-axis represent? What are the units of the x-axis?
Zeros, solutions.
Seconds.
Seconds. So when I ask for units, I just mean like, what am I measuring?
Oh.
I'm measuring time in seconds. What about the y-axis?
The height.
The height of the ball. Good. Okay, so now I have a good amount of information and I can start looking at my answer choices to see if I can get rid of anything that makes no sense. So you always want to think about, do these answer choices make sense in the real world? Starting with A, the ball returns to the ground 2 seconds after it was kicked. Is that reasonable? Could it take 2 seconds for the ball to go up and then back down?
No.
You don't think so? How many seconds would it take, do you think? In a real world?
3 seconds.
Is 2 seconds a reasonable amount of time?
Yeah.
Yeah, it is. I mean, I don't know how long it's going to take for sure, but I know that 2 is not a garbage answer, okay? It's a reasonable answer. We can keep that one for now. Cuz all I'm doing is just trying to get rid of any like bad answers. 2, or B, the ball reaches a maximum height of 1 foot above the ground. Is that reasonable? 1 foot
1 foot.
above the ground. That's like this much.
No. Yes.
It could happen. It would be a pretty bad kick. Maybe it was like a little child or a toddler doing it, but it's still reasonable. What's a number that would be unreasonable for the maximum height?
10 foot.
Yeah, 10 feet. That's really high. That's unreasonable. Or like 144 feet, that would be unreasonable. But 1 foot, yeah, it could happen. It could definitely happen. C, the height of the ball above the ground is decreasing from 0 to 1. So think about what's happening with this graph. This is the 0. I don't know where the 1 is yet, but would it make sense that the height would be decreasing from 0 to wherever 1 is? Let's say 1 is over here. Is the ball decreasing from 0 to 1?
No, it's increasing.
It's increasing. So is this a reasonable answer? No, right?
No.
It should be either increasing and then decreasing or just increasing. It doesn't make sense for the ball to be like decreasing right away, right at the 0. If it started off decreasing, then maybe it was being thrown off a cliff or like going down a slide or something, but it does not make any sense for the ball to be decreasing from the 0. It should be increasing. So good, we got rid of one answer. And then finally, the height of the ball above the ground is increasing from 0 to 16 seconds. 16 seconds. Does that sound like a reasonable amount of time?
Yes.
No.
How long is 16 seconds? Do you guys want to sit in silence for 16 seconds? Let's see how long that is. I want you guys to picture a ball being thrown in the air. So picture yourself kicking a ball in 3, 2, 1. You're kicking the ball is still increasing, still increasing, still increasing, still increasing, still increasing, halfway there, still increasing, still increasing, still increasing, still increasing, and now it goes down.
It must have been thrown. It must have been kicked by a rocket launcher.
Yeah, does that, oops, sorry, hold on. There we go. So is that reasonable?
No.
No, not at all. Unless you're in some sort of slow motion, like movie or something like that, that is not a reasonable response. So now we only have 2 answer choices to worry about. Have I done any math yet?
No.
Nope, no math. Just thinking about if it makes any sense. That's all we've done so far. And that's going to be really useful on a test because a lot of times they're going to show you some garbage answers. And you always want to get rid of those before you do anything else. That way you don't get tricked by those answer choices. So any questions on why I can eliminate those 2? Cool. Okay. So now let's look at answer choice B. The ball reaches a maximum height of 1 foot. Do I know the maximum height? I do not. Can I find the maximum height?
Yes.
Yes, how?
Using the vertex formula.
Using the vertex formula. So let's go ahead and do that. Let me move this over. Okay. Vertex formula, h equals negative b over 2a. So negative 32 over 2 times negative 16. So this is negative 32 over negative 32. What do I get?
1.
I get 1. So I get h equals 1. What are the units of that number?
Seconds.
Seconds. That's 1 second because that's my h value. So if my vertex is over here, this is 1 comma something. So that means that this 1 is the value of the time, not the value of the height. All I know so far is the time, but now I have to find the height. How do I do that?
Plug it in.
Plug it back in. So move this over a little bit. Okay, cool. Here we go. We plug it back into the original function. So h of 1. I'm running out of room. Hold on. Move things around. Okay. So plugging in my 1. And here we go. 1 squared is 1. So I have negative 16 times 1. And then 32 times 1 is 32. So I have negative 16 plus 32. What does that give me?
16.
16, positive 16. And that's my k value. So k equals 16. So the height is 16 feet. 16 feet. So 1 second, 16 feet, is B correct?
Yes.
Read it carefully.
No. B is supposed to be the ball reaches a maximum height of 16 foot above the ground.
Yeah. Careful with the units. It's not 1 foot, it's 1 second. It's 16 feet. So B had it backwards. 16 feet. So you got to be super careful. This is where it comes down to just making sure that you're reading things super carefully. It's not B, it's got to be A. And let's just make sure that A makes sense. The ball returns to the ground 2 seconds after it was kicked. Well, if it takes 1 second to reach the vertex, and we started at 0, so remember, the vertex is the axis of symmetry is 1. What has to be this number?
2.
Has
2.
to be 2, yeah. So that is correct, 2 seconds. Takes 2 seconds, 1 second to go up and 1 second to come back down. So the strategy with these types of problems, especially if it's multiple choice, is first things first, look at your equation, figure out what form is it in, and what do you know about the function. You can draw a little graph, a little sketch, just to get an idea of what it should look like. Okay, so that was step 2. Step 3, get rid of the garbage answers. And step 4, you figure out between the remaining choices which one makes the most sense usually you're going to have to find the vertex and use the vertex formula and then go from there. So we're going to be looking at a lot of questions today, kind of like yesterday's class, that are word problems. And we're going to get used to that sort of strategy of, writing down everything you know, making a sketch, and then narrowing things down a little bit more. So any questions on this bell ringer before we go ahead and continue? All right, cool. So I just wanted to start off with a little bit of a review of just graphs, no word problems yet. I just want to make sure that we're all on the same page. So take about 30 seconds to a minute and in your head or down on your notebook, start writing down the answers to each of these questions. So where's the y-intercept? Where's the x-intercept? Vertex, axis of symmetry, max and min. We're just reviewing. Okay, about 10 more seconds. See how many you can get. And time. Let's go through it. Shout it out if you know the answer. I already see Juan put down one answer in the chat. The y-intercept is at -3. Good. There's my y-intercept. All right, where are my x-intercepts?
-3 and -1.
-3 and -1. Good. So -3, 0, -1, 0. Awesome. How about my vertex? Where's that?
-2, 1.
-2, 1.
I did it wrong. I did it backwards.
Yeah, you did 1, -2, so just be careful. You know, those little things, it's easy to mess them up, so we got to make sure we do them right. Axis of symmetry, where is that?
-2.
-2, good. Right down the middle. And just remember, this is x equals -2 because it's going through the -2 on the x-axis. So the axis of symmetry is at x equals -2. And finally, do I have a minimum or do I have a maximum? Is this a minimum or is this a maximum?
A maximum?
Yeah, it's a maximum. It's a tippity top. It's a maximum. So we have a maximum. What is the maximum value?
Is it 1?
It is 1, yeah. It's at y equals 1. So when they ask you for the maximum, you always want to, kind of similar to the axis of symmetry, you can do this. You can kind of draw a line at the highest point and see where it passes through. It passes through the 1 on the y-axis, so y equals 1. So take a moment to just make sure that you understand all of these points because this is the basics, okay? It's important to know the basics. That way, later on when we use word problems, we can understand what they all mean. Do I have any questions? Awesome, awesome. All right. So graphs are awesome because you can see things a lot more clearly, but they're not always going to be what you get. More often, you're going to just have an equation or a word problem. So we're going to start off with just a couple of equations, and we're going to do the same kind of thing. We're going to identify some key features. It's not going to be as many as this problem because equations don't always tell the full story, but they can get you pretty close. You can learn a lot just from an equation. So first of all, anytime you see an equation, we're going to identify what form is it in and what do we already know. So what form is this in?
Standard.
Standard form, good. It's in standard form. So let's just identify everything, all the different variables that we know. So we know that standard form has A, B, and C. So what's my A?
48. And then -16.
-16. My B?
+8.
And my C?
48.
Good. Okay, now from there, we kind of can figure out what we already know about this function. So based on these numbers, what do I know?
The y-intercept
Good. Where is the y-intercept? Which of these
at
is
48.
it? At 48. Good. So that's my y-intercept. So I know that this is 0, 48. Now, what else does this do? These numbers, one of these numbers tells me something else important. Does the b tell me anything?
You could put it in vertex formula.
I could put this into the vertex formula, that's true. But does it tell me anything on its own?
No, it doesn't. The A,
No. The A does, yeah. What does the A tell me?
it tells you what the direction and the shape / width of it.
Good. So in this case, -16, I know that I'm facing which way?
Downward,
And I'm
stretching.
stretching. And that's really good information because what I already know is that it faces downward. So is the vertex going to be a minimum or is it going to be a maximum?
Maximum.
A maximum.
A maximum. And you can draw a little sketch of what you know the graph is going to look like. It's going to go downward like this. And so wherever the vertex is, doesn't matter where it is, it's going to be a maximum point. It's going to be the tippity top. So it's a maximum. But now we can actually figure out where the vertex is located. And this is where I'm going to have to use my, how do I figure this out?
Using the formula.
Using the formula. So we're going to use the vertex formula. It's the only way. You can't figure it out any other way. You have to use the formula. So that's going to be negative b over 2a. So that's -8 over 2 times -16. So -8 over -32. You may use a calculator. What do we get for h?
Is it 1/4?
It's 1/4. 1/4. So since we're using calculators, we can turn this into a decimal. What is 1/4 as a decimal?
0.25.
Good. So we know the h value, and then you always got to plug it right back in to find the k value. So I'm going to have you guys do this part on your own. I'm not going to say anything. Go ahead and using your calculator, see what you get for k. Plug everything in and make sure you follow PEMDAS. Go ahead, take a moment.
Didn't we do this before?
You might have seen this equation before, yes.
Do we enter it in the chat?
Yeah, you can put it in the chat. I'll give everyone about 30 more seconds. All right, 5, 4, 3, 2, and 1. So over here, 0.25 squared, you get 0.625, and when you multiply that times -16, this all gives you -1. 8 times 0.25 is 2. So we have -1 plus 2 plus 48, and that gives us 49. So k equals 49. So the vertex is where? What order does this go in for the vertex?
0.25, comma 49.
Good. All right, so vertex formula, super useful, obviously, because now we have a very clear picture of what the graph would look like. So I'm going to do a quick little sketch. Now, while I make my sketch, what is the only thing that I don't know at this point? I know my y-intercept. I know my vertex. What am I still missing?
X's.
X-intercepts, yep. So my y-intercept is at 48. My vertex is at 49. And I know it's downward, so it's going to go something like this. But I don't know where those x-intercepts are. So standard form can get you most of the picture, but not the full picture of what this graph looks like. All right, any questions on this whole problem? Take a moment, make sure that you understand. Remember what I said, today I want to see questions in the chat. I want to hear participation. I want to see participation. Today's the day to make sure that you're understanding everything. And if you don't understand something, today's the day to ask.
Is it a possibility that you could find the X just by looking at it? Because if it starts at 0, that means it will like be 1 or something, right?
It looks like it's going to be 1, but you can't know for sure without doing
the other side is not viable. It can't be a wait.
Well, this is not a real world scenario, okay? This is just an equation. If it was a real world scenario, then the negative side would not be viable. But in this case, it's just an equation, so we don't have to worry about that. And to answer your other question, there is a way to figure out where these x-intercepts are, but you're not going to learn about that until after your tests. So I'm going to keep you waiting, keep you on your toes. All right, so we all good? Any questions? All right. Let's try another one. Now in this case, same idea. We're going to start with what do I know and then figure out what we don't know. So what form is this one in?
Vertex?
Vertex form, good. How can you tell when something's in vertex form?
It has parentheses and it is squared. The parentheses are squared.
Good. Parentheses and an exponent, vertex form. Now, vertex form tells us a few pieces of information. We have A as usual. And what else do we have? The vertex, yeah. So I know I'm going to be able to figure out what is H and what is K. So first of all, A, what is A? -16, good. So A is still always going to be the leading coefficient. What's my h? Positive 4. Awesome. And my k? 256. So remember, with h, we got to flip that sign. It was negative, we turn it positive. For k, we leave it, 256. Any questions on A, H, or K? All right. So that means that I know that my vertex is where?
At -16, no, at 8 at 4, comma 256.
There you go. Good. H, comma, K. You got it. Okay, cool. And then the -16 tells us a little bit of info. What do we know from here?
That it's downwards and a stretch.
Good. So will this vertex be a minimum value or a maximum value? Good, Lauren, it's a maximum. Similar to the previous problem, right? So this one, we know it's downwards. So wherever the vertex, this is 4, 256, that's a maximum value because it's at the top. But we don't know the y-intercept at this point, but we can figure it out. How would I figure out the value of the y-intercept? Let's see if anyone can think. I'll give you guys a hint. Which form tells you the y-intercept?
Standard form.
Standard form. But I'm in vertex form. So what can I do to...
So you have to FOIL. So we have to break down the parentheses by doing 16 parentheses 2 subtract 4. Then you duplicate it.
Exactly. Duplicate it. And we're going to expand. Okay, it's called expanding because that's what we're doing. We're expanding this vertex form equation in order to turn it into a standard form equation. And once we do that, we'll see the value of the y-intercept. So let's get right into it. So why did I duplicate t minus 4?
Because it's squared, so that means it's being multiplied by itself.
Yep, good. So now I have to FOIL, so let's go ahead and FOIL. And this is something that I definitely want everybody to be writing in their notebooks because the more you write this process, the easier it gets to remember how to do it. So once you FOIL, let's see, what do I get? T times t?
2 to the power, no, t to the power of 2.
T to the power of 2, good. T times -4?
-14.
-4t, good. And then again, -4 times t, we get -4t again. And now -4 times -4?
16.
16, good. Okay, what should I do in here now?
Simplify, combine like terms.
Combine like terms, good. -4 and -4 give me?
-8.
-8. So t squared minus 8t plus 16. And then I have my 256. Now what can I do?
Distribute.
Yeah, we're going to distribute. So I have -16t squared. What's -16 times -8? You can use a calculator. I'll let you do it. Good, 128. And then -16 times +16.
-256.
negative 256. Well, now I got plus 256, so what happens?
Add like terms again.
We
Oh, no.
combine like terms. Yeah, and what do I end up with? They cancel out. They cancel out to 0. So what's my y-intercept?
0.
0, yeah. 0, 0. They cancel out. We're left with 0. Now, that 0, I would never write that into my final equation. So my final equation would just be this. But we know that that 0 is there, okay, because this is my b. So if you don't see a constant, then that means the constant is 0. So this process, super important as well, to make sure, first of all, that you know how to do it, but second of all, that when you're doing it, you take very, very careful steps with your negatives and your positives. So take a moment, again, make sure that this is all written down in your notebook and see if there's any questions that you have for me.
When it comes to this problem, do we always duplicate the equation?
Yeah, so when you have a vertex form equation and you need to turn it into a standard form, so let's say the question is asking you, like, what is the y-intercept? You're going to need to turn it into standard form. So anytime you do that, you have to duplicate what's in the parentheses because we're squaring it. And when you square something, that just means you're multiplying it times itself, right? So t minus 4 times itself, t minus 4.
Okay.
And someone in the chat is asking me if it's down. Yeah, it is facing downwards. So actually, let me do this last step and I'll do a quick little sketch of what it looks like this is going to look like. So it's facing downward. It's starting at the origin. So I'll do it like over here. It's starting at 0, 0, and it's going to 4, 2, 3, 4, 4, 256. So I'll make this 256. The y-intercept is 0. So it's going to go up. Hold on. It's going to go up to the 256. And here's an interesting, this one's a little bit different. Let me explain. Since I know that the vertex is at 4, 256, and I know that this is one of my x-intercepts because it's starting at the origin, so this is both a y-intercept and an x-intercept. Where would my other x-intercept be on the opposite side?
8.
Good. Why?
Because when you count to the AOS from 0, it will equal 4, and then if you continue on to like a number that equals 4 to the AOS, it will be 8.
Yeah, so the AOS, the axis of symmetry, is always down the middle. So if this is 4 units away, then it's got to be 4 units away on the other side. So for that reason, if one of my x-intercepts is at 0, the other one would have to be at the 8 because it's halfway. It's like the halfway point. So now I can draw a much nicer graph than originally. Let me move this over. Okay, here we go. There we go. So that's a pretty good sketch of what it looks like. Any other questions? No? Okay, cool. Let's do a third example. Now in this case, what form am I in? Factored form. My favorite, personally. So it's in factored form, which means we're going to do a little bit of work, not too much work, but just a little bit. And what do I have to do to each of my two factors?
You you turn them. You find the x-intercept.
So I'm looking for my x-intercepts. So for each of these factors, I need to make them equal what?
0.
0. So 2x plus 3 equals 0, and x minus 2 equals 0. Now one of these is easier than the others, but all we got to do is solve for x. So what should I do to both sides?
You have to subtract 3, and then on the right side add 2.
Good. So here I get 2x equals negative 3, and here I'm adding 2. So I got x equals 2. So this one I'm done already. But on this hand, what do I still need to do?
You have to divide.
Yeah, we're just going to divide by 2. Negative 3 over 2, what is that as a decimal?
Negative 1.5.
Good. And those are my what?
Oh, x.
Zeros.
My zeros, my x-intercepts, exactly. So I can already fill that in. So I know I have negative 1.5 comma 0 and 2 comma 0. And that's from the equation. So sometimes you have to do a little bit of work, but most of the time it's actually a lot easier because you just flip the sign and that's all you have to do. But in this case, since I had a 2 in the front, a coefficient, we had to do a little bit more work. So you just want to be careful with these factored form equations. And what I would say is just do it the long way no matter what. That way you know for sure that you have the right answer. If you rush through it, you might have thought that this would be negative 3 and positive 2, but it wasn't negative 3, it was negative 1.5. So just be a little careful with that. Any questions on finding the zeros? Okay, so I'm going to bring this up to here. And, oopsies. And what else do I know about this function? Based on the equation. What else have I not really looked at yet? Yeah, a equals negative 8. Now what does that tell me about my graph? It's downward and stretched. They've all been downward and stretched so far. I didn't even notice that. Okay, so that's going to be also helpful because what does that tell me about the vertex? Minimum or maximum? Maximum. Good. All right, I'm going to erase my work over here so I can have room for what else I have to do. Because now I still need the y-intercept and I still need the vertex. So there's a couple of different ways to do this. Who can tell me one way to find the y-intercept? I'll give you a hint, it's very similar to the previous problem.
We have to turn it into standard form.
Yeah, we got to turn it into standard form. Same as the previous problem. If we turn it into standard form, we'll know where the y-intercept is located. So let's go ahead and do it. What should I be doing first?
FOIL?
2x times x. 2x squared, good. 2x times negative 2. negative 4x. 3 times x, 3x, and 3 times negative 2, minus 6. Awesome. Next step, what do I do?
Simplify. Combine like terms.
Combine like terms, simplify. What's negative 4 plus 3? Plus 3.
Negative 1.
Negative 1. Careful. So I have 2x squared minus x minus 6, and then finally I can
Simplify. Distribute.
distribute. Alrighty. What do I end up with?
What is with negative 16x squared?
They love that number. Okay. Plus,
Positive 8x.
and what's 8 times 6? 48. Good. So there we got our y-intercept, 48. Zero comma 48. All right, questions on how to turn this into standard form, or questions on anything on this page so far? All right. Okay, so we're down to our last part of this, which is the vertex. And at this point, there's two possible ways to figure out the vertex. Can anyone tell me one way to do it? Yeah, now that I have a standard form equation, I can use the vertex formula. Was I able to use the vertex formula before I did all this?
No.
No, right? You can only use the vertex formula when you're in standard form. So that's one possible way to do it. And in this case, that's probably the best way to do it because there is one more way. There is one more way, which is remember that the vertex is going to be right in the middle of the two x-intercepts. But in this case, the middle between negative 1.5 and positive 2 is a little harder to find. So you could do it that way, but we're not going to do it in this case. However, I think we've seen this question, these numbers before, haven't we? Yeah. I just realized that these are the same exact numbers as we did in this problem. So we've actually already found the vertex before. This is the same exact equation. So we have the same exact numbers. Now, does anyone want me to go through the vertex formula again? I'm happy to do it again, but we already did it. Okay, we're gonna do it on a different problem, so I'm not gonna do it now. But since we already did this, I know that this is 0.25, comma, 49. But hey, what do I know now that I didn't know when we did it during this problem?
The x's.
Yeah, I know the x-intercepts now. So I can get a much clearer picture of what this graph is going to look like. So let me go ahead and do that, and then we'll move on. So now I basically have everything I need to know. I know my y-intercept, I know my x-intercept, and I know my vertex. So the y-intercept was 48. I know the vertex is at 0.25 comma 49. And I know that the x-intercepts are 2, so I'll make this a little bit bigger. 2 and negative 1.5. So here's my 2. Here's my negative 1.5. My vertex is at 0.25 comma 49. And my y-intercept is at the 48. So now I have all the pieces of my puzzle. Okay. So obviously it's not a perfect drawing, but it would look something like this. How do we feel about this? We just put everything all together. So everything we've learned the last 2 weeks all into one problem. How do we feel? Any questions? No questions? Alrighty. So we've been doing just equations up to this point, but now let's start talking about word problems or like scenarios. So in this case, I have a graph, which is lovely. I love when I have a graph. And it's tied to a real world situation. So can I get a volunteer to read our little scenario, please? What does this graph represent? Volunteer, let's do this, guys, come on. Participation.
I would read, but I already read.
Yeah, you already read. I want to hear from someone else. Let's go. Who's gonna go?
Awkward silence.
I'll sit here in awkward silence till I hear from someone. Karina, go ahead.
Biologists discovered an invasive bird species on an island. The function F models the population size in hundreds of birds for this species as a function of time in months after being discovered.
Awesome, thank you. That wasn't so hard. Okay, so first thing, let's find all of the values that it asks for, and then we'll go into like what they actually mean. So where's the y-intercept? Where is it? You can find the exact value. Should I zoom in? Yeah, okay. Y-intercept, where is it?
Sort of at 16.
Not even sort of, it's right on the 16.
Oh.
Yeah.
I thought 16 would be like in the middle or something.
Nope, it's going right through the 16. So the y-intercept is 0, 16, and we'll talk about what it means in a moment. But next, the x-intercepts. -2 and +8, good. And the vertex. Give me a full coordinate point. So if you
3, 25.
Yeah, that's at the 3, right? It's a little hard to, yeah. 3, 25. Cool. Okay, now let's talk about it. So the y-intercept is 16. 16 what? What is it measuring? And you can look at it's labeling. Good, the size, the population size. And it's telling us that that's the population size in hundreds. So how many birds are there? If it's on the 16, what does that mean?
There was 1,600 birds were there at the start.
Good. At the start. So that's a key word. It was at the start. So it looks like they discovered it, right? So maybe this is the day where they started counting how many birds they could find. And they found 1600s on the first day. Okay. Then I've got x-intercepts, but actually I want to do the vertex next. So the vertex is 3, 25. What is the 3? What are the units of this one?
300. Oops, 300.
3 months. So careful, because the 3 is this number. So it's 3 months, but it's 25.
I always confuse the Y and the X.
That's okay. And it's 25 what?
2,500. 2,500.
2,500 birds. So putting it together, what does that actually mean? So who can give me like a sentence that explains what this actually means?
It means the AOS.
But give me words like, explain to me what actually happened in the real world.
So once the birds reach their highest like growth or maximum, the highest of them, I mean, like when they reach the 3rd month and they reach their highest growth, at some moment, let's say like the environment changed or whatever, they started to become extinct.
Good. So that's a really good way of explaining it. That's exactly what I wanted. So there's the mathematical language, but then there's like the real world, like tell me what's happening, right? Yeah. So after 3 months, the birds or the bird population reached its maximum of 2,500 birds. And after that, it began to decrease. Okay, and now x-intercepts. So those are a little bit more interesting, right? Because I have 2 x-intercepts. Well, let's talk about that. Can I use both of them? Do both of the x-intercepts make sense? Guillermo's telling me no in the chat.
No, because since it's a real world thing, the negative side will not be viable.
Good. So anything that happens on this side of the graph is not viable because we can't go back in time. But what about the other x-intercept, the 8? What does that tell me in the real world? So it's 8 birds or 8 months?
Months.
8 months. So who can give me a sentence explaining what that actually means in the real world?
What was the question again?
Who can give me a sentence explaining what this number means in the real world?
Can I explain, or I have to, or someone else have to?
I want to see if someone else can do it since you already did one of them. Who can explain? So it's 8 months. What happened after 8 months?
There are no more birds.
There are no more birds, basically, yeah. So after 8 months, there were no more birds. So this could have happened for a variety of reasons. Like Ajira said, it could have been something environmental or if you read the problem, it says that the population of birds, it was an invasive species, which is not a good thing. Invasive species can like really mess up the environment. So maybe the scientists or the biologists found a way to have them leave or die, or who knows what they did. But in any case, there were no more birds after 8 months. All right, so that's basically how it goes when you see a graph like this that actually has something to do with the real world. It's important to understand what all of the different parts of the graph actually are telling you. Do I have any questions on this problem? Guillermo says this is like the dodo bird. Yeah, the dodos, they died off in the Ice Age. R.I.P. If you guys ever have wondered, if you've watched Ice Age, first of all, which is such a good movie, if you've ever watched Ice Age, you know the dodos who like they have the watermelon and they're like they keep like jumping off the cliff because they're kind of dumb. Look up how big a dodo bird is and it's going to blow your mind. That's all I'm going to say. All right. I have the same graph, but now I have two different questions. I want everyone to take about a minute to think about these questions and see if you can answer them. Take 1 minute.
Answer this in the chat.
In the chat, yeah. All right, take another 30 seconds. All right, so let's now think, now that you've had some time to sort of think about it, let's actually try this. So reading carefully, by how much did the bird population increase from the time they were discovered? So when were they discovered? When did they discover these birds? On the graph, where is that point? Where did they discover them? Over here, over here, over here, over here. Where? Where were they discovered? When there were 6, yeah, at the big, where's the beginning? In other words, where is the beginning? What point on the graph is that referring to?
The y-intercept to the vertex.
So this is asking me from the y-intercept to the vertex because it's asking me how much did it increase by? So it's increasing, 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 increasing up to this point. Oops. From there, from the vertex, it's going to start going down. So it wants to know by how much did the bird population increase from the moment they were discovered. So when they discovered it, how many were there? I think Karina said it a couple a little bit ago, 1600, right? So there were 1600 at first. By how much did it increase? $900. How do we know? It went up to what?
250, 20, 200,
20,
2500.
2500. So that means 2500 minus 1600.
Oh, 1600. I thought it was 1500.
Oh, it started, yeah, at the 16, don't forget. So this gives me 900. So it increased by 900 birds. After that, it started going down, right? So when it asks you this, you have to make sure you know where you're looking. You're looking from the beginning, from the y-intercept, to the maximum. Any questions on that one? Okay. And then what is the interval during which the bird population decreased? So from where to where is it decreasing?
3 to 8.
So from the vertex
Oh, 8. To the x-intercept 8.
to the x-intercept 8. So you said 3 to 8 because this is at the 3.
And it's asking for an interval, so it's gonna be about time.
Good. Remember that intervals are time intervals. So the time is from 3 months to 8 months. So when we write that as an inequality, how would I write that? An inequality. 3, sorry, hold on. 3 is less than, not 0, but 3 is less than x is less than 8. That would be my.
I'm kind of confused about that because I thought we had to count all the way, so that's why I said 5 or 8.
So okay, so it's a total of 5 months. This is a total of 5 months, but the interval, the way you write an interval is you just tell me where does it start, where does it stop. So from 3 to 8, which equals 5 months. Oh, I love the positivity. Good job, guys. Any questions on this one? So just want to make sure that we understand, like, because these are two very common questions, and you have to make sure you know what they're looking for when you see that type of question. So anyone have any questions? Cool. Okay. It is 10:24. Let's see. I want to do one of these word problems, just one. But let me find the best one. There's three that we can do. I think let's do this one. Okay. So a ball was thrown upward into the air, and then the height in feet of the ball above the ground, t seconds after being thrown, can be determined by the expression -16. They love that number, -16 t squared plus 40t plus 3. And we have a bunch of questions. So we're going to have to kind of break it all down and think about what do I know and what do I not know, and how do I find what I don't know yet. So let's start with, what form is this equation written in, or this expression?
Standard.
Standard. And since this is in standard form, what do I know?
You know, the y-intercept.
I know the y-intercept. So I know there's A, B, C. And which of those is my y-intercept? What is my y-intercept? Yeah, C. Cool. So if that's my y-intercept, what does this represent in this problem?
What are we answering again? I'm sorry.
What does the y-intercept represent in this problem?
Starting point.
The starting height.
Height.
Yeah. The starting height. Remember that your y-intercept is pretty much always going to be the starting height. The starting value of whatever we're talking about. So be careful because, Lauren, sometimes it is the maximum as well, but not always. So we always have to be very careful with that. It's always going to be the starting amount, and then sometimes it's also going to be the maximum amount, but not always. So based on that, which of these questions can I now answer? I can answer A, yeah. How many feet from the ground was the ball thrown? That's asking for the starting height.
Yeah, 3 feet.
So 3 feet from the ground. Cool. Can I answer any of the other questions at this point?
No.
No, because what am I missing? In order to figure out the maximum, what do I have to find?
Vertex.
I have to find the vertex. So what's the only way to find the vertex? The vertex formula. Good. Vertex formula, my favorite formula. Actually, it's not my favorite formula. I have a better formula, which we'll learn later this year. Okay. Negative b over 2a, that's going to be negative 40 over 2 times negative 16. So that's negative 40 over negative 32. Go ahead and use your calculators. What do we get?
Did this before.
Did we? Interesting.
1.25.
1.25. What are my units?
Seconds.
Seconds, good. Which of my questions can I answer now?
C.
C, good. It's asking for seconds. So we know it's not asking, or this is not the height, this is the amount of time that it takes to get there. So it's not going to be answering question B, it's going to be answering question C. But in order to answer B, what am I going to have to do to this number?
Plug it in.
Plug it in. So K value, we got to plug it back in. K is going to be negative 16 times 1.25 squared plus 40 times 1.25 plus 3. All right, take a minute. Take 1 minute to try this on your own using your calculator. Tell me your answer in the chat and I'll tell you if you got it right. Okay, take about 10 more seconds. Again, send me your answers in the chat if you have them. That way I can check. All right. 5, 4, 3, 2, 1. So if you don't have an answer, if you didn't send me an answer, I want you to tell me right now in the chat why. Are you confused? Are you unsure? You don't really know what you're supposed to be doing? Tell me your reason in the chat. You didn't get it yet and you were almost there, but you didn't get it yet? Tell me what happened. Because when I only hear from 2 people, that's a problem. Tell me your reason. I need to know. I'm your teacher. Miss Lopez, hello. I am your teacher. I need to know why my students are not getting answers. Tell me in the chat, please. Did you go too slow? You don't know what you're doing? Or you got lost? Those are the only 3 options that I can imagine. Send me your and tell me what the reason is so that don't be afraid. I'm not judging you. I just need to know what the problem is so that I can fix it. Okay. That's very helpful. Okay, guys, I can't stress this enough. If I'm in the classroom, I can walk around the room and I can check your work and I can say, oh, okay, Lauren, you forgot your negative sign. Jade, you didn't add correctly. Juan, good job, you got it right. You know, I can go around the room and look down at your piece of paper and make sure that you know what you're doing. But I can't do that right now. So in order for me to know how to help you, you have to tell me if you're having a problem. You can't just let me keep going without explaining to me what the issue is, because now I know that I need to go over how to do this. Here I was thinking that you guys already know how to do it perfectly, but clearly that's not the case. So as your teacher, I need to be aware of why you're not getting the correct answers. And I need you all to be way more proactive about telling me if you have a problem. So if I say you have 10 seconds left and you don't have an answer, I need you to tell me in the chat why you don't have an answer. And don't be shy or ashamed. I'm not judging you. I'm your teacher. I'm not here to judge you. I'm here to make sure you understand how to do things correctly. So it's way more helpful to me if you tell me why, whether you got lost or you're not sure how to do it, or I don't know, whatever it is. If you tell me, then I can help you. And if you don't tell me, then I can't help you. Do you see the problem? So I need you guys to be better at that. I need you guys, it is frustrating to me when I have to keep saying it over and over again. So let's go ahead and do it together. The math looks complicated, but guess what, guys? You have a calculator for a reason. I'm not telling you to do this in your head. You have a calculator, so use it. Following PEMDAS, what do I have to do first?
Exponents.
Exponents. There's only one exponent. So I'm doing 1.25 times 1.25. Use your calculator. Tell me in the chat, what do you get?
1 point, oops, sorry.
Let everyone else, let everyone else have a chance. So in the chat. Now, if you're not sending me an answer right now, that means that you're not even trying, because this is not a hard thing to do in your calculator. So I should see 12 answers in the chat right now, because I have 12 students in this class. What is 1.25 times 1.25? I'm still waiting. I've only heard from 4 people right now. It seems like you guys want to have your cameras on after spring break. 5 people have answered me. 6 people, 7 people. Thank you. We get 1.5625. Now I'm just going to bring everything else down. I'm not going to do it all at once. If you try to do it all at once, that's just an opportunity to make mistakes. Now I can multiply, and I'm doing negative 16 times 1.5625. Does everyone know how to use the negative symbol on their calculator? Or does anyone want me to show you how to use the negative symbol on their calculator?
Actually, it's not, I don't think it would be, you could use the negative symbol, but at the same time, if you see a negative, like you know that it will be a negative at the end of the day. So.
Exactly, yeah. So you could just plug in 16 times 1.5625. If you do that, if you just put 16, you're going to get 25. But we know that it's going to be negative, so I can just bring down that negative sign. So it's negative 25. Now over here, 40 times 1.25. Send it in the chat. I want to see 12 responses.
50.
50. And then I have my 3. So now this is just very simple math. Negative 25 plus 50, what do I get?
25.
25. And 25 plus 8, or plus 3, I'm sorry. I get 28. So when you're doing the vertex formula, okay, yes, the numbers can get kind of large, or there might be a lot of decimal numbers, or this big equation looks kind of scary. But when you break it down into each individual step, and you have a calculator, it's not as hard as you think it's going to be. You just have to make sure you take it slow, and you go step by step, and you check your work. Don't rush through it. And most of the time you end up with a pretty nice whole number. Not all the time, but most of the time you do. Even when we started off with these crazy decimals, we got a whole number as the answer. So I don't want you guys to just, if I say you have a minute to do this problem, don't just sit there and stare at your screen and think you can't do it. How do you know you can't do it if you don't try? And if you try and you get lost, tell me. That way I know that I need to go over it. Because as a teacher, it's very easy to just think that your students know how to do something. And sometimes they do. Sometimes I'm right and I know what my students know. But a lot of times I think you know how to do something and it turns out that I'm wrong. And that's okay, but if you don't tell me, it's only going to get worse and worse and worse, and you guys are going to get more and more lost. So it's better to just let me know so we can take care of it, and then we'll be good going forward. So are there any questions on this math?
This is where my sloppy writing got the best of me. I thought I wrote a 3 at the beginning, but I thought it was a 5, so I continue with the 5.
Oh, this number, this 3, you thought it was a 5? Yeah, okay, so see, little things like that. Even if you know how to do it, that's not a guarantee that you're going to do it right. So
I sort of wrote it down as a 5. I was quick because oh no, 30 seconds left.
All right, so 28 is what are my units of that, by the way? Let's not forget what we're doing here.
28 feet.
Feet, good. And that's the maximum height. All right, now we only got 5 minutes, so let's make the most of it. So now that I have everything all put together, let's read the last problem and try to figure out what it's asking for. It's asking, what is the interval during which the ball is increasing? So I'm not going to draw a graph yet, but picture a graph we've seen enough already, so you should be pretty easy to picture this. We have a graph of a ball that's going up and then back down. What part of the graph will the ball be increasing, going up? From where to where?
From 3 to 28.
Okay, so it starts at 3 feet and it goes up to 28 feet. But remember that intervals mean time.
So from 0 to
Zero.
1
So
and
from 0
1.25.
To 1.25.
Good. From 0 to 1.25. And I'll show you that on the graph in a second. So 0 to 1.25, that's going to be 0 less than x less than 1.25. Now let me draw it all out so that we can get an idea of what that actually looks like. Oops, I lost some letters. There you go. Okay. So here's my little graph. So I know a lot of information. I know that my y-intercept is 3. I know that the vertex is 1.25 comma 28. So if this is 1 and this is 2, here's 1.25. Now it goes all the way up to 28 feet. So I got to fix this. I need to make a little bit more room for myself. I'm just going to move this up here a little bit. It goes all the way up to 28. So I'm just going to make this a little bit longer. And it's not going to be perfect, but it's it just gives us a good picture of what it might look like. So let's say that this is the 28. Here's the 1.5. And it's going up from the 0 to 1.25. From 0 seconds to 1.25 seconds, it's going up. And then, of course, gravity, it's going to come back down. Do we know where it's going to end?
No.
We don't. And unfortunately, we can't really figure it out in this problem. But we know it's going to be more than 1.25. So what's a good estimate for this number here?
1.25. 2.
2. 2 is pretty good. Could be 2, maybe a little more than 2.
3.
Yeah, like 2.5 or 3. Now I don't know. I actually do not know.
2.50?
So 1.50. Careful, because 1.50 would be like over here somewhere.
2.50.
Oh, 2.50. Yeah, 2.50 I would say is a good guess as well. So we don't know for sure, but we can kind of estimate approximately where that's going to be. So that is everything for today, you guys. We did a lot. We've put it all together. And now you get to enjoy your break. But really quickly before you go, there is going to be a spring break packet that is extra credit. I'm going to post it on Teams, and it's going to be due the day we return from spring break. So that's April 5th. In order to earn extra credit, you have to do all of it. So just at least attempt every problem, and you have to get 50% of it correct. The extra credit will be added to your topic test score. So that's big points, because topic tests are the majority of your grade. So if you earn extra credit, that's going to bump your grade up a lot. When you complete it, all you have to do is text a picture of your work and your final answers to my Remind or my Google phone number. And I'll post all of this on Teams. So if you don't take a picture of it right now, it'll be on Teams later on today. And then last little thing, I know it's time to go, but really, really quick, I just want you guys to see what's going on in the next month or so. So this is spring break. We come back on the 5th. We're going to do a review. Then it's the topic test and the makeup for the topic test. And then from there, we have one more topic to learn, but it's not that long. So we're going to be learning new information for about 2 weeks. You're going to take a quiz on it, not a topic test. So this is going to be a shorter quiz on topic 10. And then from there, we're just going to review. And your EOC is scheduled for May 26th and 27th. So I will also be posting this on Teams later today. So just look ahead for that on Teams. So that's basically it. Have a lovely spring break, everybody. I hope that you get some rest, and I'll see you all in a week or so.
See you next month, Miss Lopez. Have a nice
See you next month. Yeah.
Message?
I saw your message, RL. I wrote it down. I got you.
Okay, thank you.
You're welcome. Bye, everyone.
Bye.
Have a great week.